Okay, let's talk about geometry. And what I'm going to be doing in this video is kind of powering through what's pretty typical for like the first chapter of a high school level geometry course. So if you have to study geometry, maybe you're going to be taking geometry or you need to review some geometry for whatever reason, this is going to be a very helpful video. But basically, I'm going to be laying down the foundations to geometry. Matter of fact, let me show you what I'm going to be covering in this video. It's going to be a lot of material. So the first thing is we're going to talk about points, lines, and planes. So then I'm going to get into line segments and rays, angles. Then we're going to talk about theorems and postulates. And I'm going to be giving you a lot of information pretty quickly, but I'm going to give you some suggestions on how you want to follow through and continue your study of geometry. But this is going to be an excellent kind of quick review or introduction to the topic. But before we get going, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. I've been teaching math for decades, and over those years, I've learned basically one thing, and that is all students can be successful in mathematics, but it requires two things. One, the student has got to be willing to work, study, and practice. And the second thing a student needs to be successful is great math instruction, clear and understandable math instruction, so I can help you out with that. So if you're at the middle school, high school, or even college level and you need assistance in mathematics, definitely check out my math help programs. I'm going to leave the links to all my stuff in the description of this video. By the way, if you happen to be preparing for any sort of test with the math section, I'm talking about things like the GED, SAT, ACT, teacher certification exam. I also have test prep courses that you might want to check out. If you homeschool, I have excellent, full, comprehensive middle and high school math courses. Matter of fact, if you are in high school level geometry, I have excellent, complete, comprehensive high school level geometry course you can find in my math help program. And I'm going to leave links to my math notes also in the description of this video. Okay, so let's get going. This is a lot of material, and this is just going to be a quick um, overview of all this stuff. Again, this would cover kind of like the first couple weeks of a typical high school level geometry course or like a first chapter. So I want to be going through things. I'm probably not going to cover every single little thing in detail, but again, I'm going to be giving you a lot of information. So let's get going. All right, so let's start off with points, lines, and planes. So what we're going to be doing here to establish the foundations of geometry is to start giving you some definitions. We've got to start talking about concepts, and we have to break things down in its smallest parts. But when we think about geometry, we think about things with points, like here's a point there, and then we have lines, and then planes are kind of like, think of it like as a piece of paper turned to its side. That would be the concept of planes, but these are kind of like the building blocks, like the DNA that make up geometry. But check this out. This is kind of crazy. These terms cannot be defined. Okay, so you're probably saying to yourself, what are you talking about? A line can't be defined. I know how to define a line or a point. Well, I can tell you right now, you think you may be able to find a point. Let's play this game here real quick. Go ahead, in your own words, define a point. So just think about this for a second, okay? What is a point? So some of you are going to be like, well, it is a little dot I write on my paper, or it's a little circular thing, or it's a, if you start kind of really exploring this, this becomes very difficult to define. So there are some things in mathematics that we just kind of say, hey, we can't really define them. We know what they are, but we can't give a definition to them. So points, lines, and planes fall under that category, okay? All right, so first things first, let's talk about what a point is. Now, we can't give a definition of to it, but we basically have an intuitive understanding that a point is like a little one spot in space. So here is an example of a point there, and we can label that point as with a letter, like point A. So this would be point A. All right, how about lines? Well, this is a line right there. We kind of recognize what a line is, and how do we name a line in geometry? Well, if there's 2 points that are on that line, like for example here, A and B, this would be the notation for this line AB. So we can write or describe this line as line AB. So you just put these points here. These are not what we call endpoints. These are just points that happen to be on the line, and then you draw a little line with 2 arrows emanating like so. Okay, so that's one way you can name this line. Another way you can do this is what you could see right here. I could just put a little letter. I can call this line L, for example, and that is another way to name a line. Okay, so let's talk about planes. Again, a plane is something like, you kind of think of it, it's a two-dimensional like piece of paper turned to its side. And, of course, we could have points that are on there, or like think of it like as a football field or something conceptually. Now, planes, they go out infinitely. Okay, they don't stop. They go out infinitely to each side, but of course we, can't really write it that way. But when you look at a plane like so, we can just draw a little figure like this and name it like plane M. Okay, so these are some basic terms. Again, we're starting with the fundamentals of geometry. Let's move forward and give you more terms and definitions because there are a ton in geometry. So let's go and start off with this first term and take a look at collinear. You need to know what this word means, collinear. And basically, that means we're talking about points that are on the same line. Okay, so points that are on the same line are called collinear. All right, so here's an example. There's a line. Here's some points that are on the same line, collinear. So what do you think non-collinear points are? Well, those are points that are not on the same line. So here's a line. So these would be non-collinear points. Okay, continue to move forward. Let's talk about coplanar. Okay, so coplanar, you probably guessed these are points that are on the same plane. So here's a little plane, and these points are on the same plane. So maybe, if you have a point over here, that would be non-coplanar, but this is coplanar. Okay. All right, moving on. Now, anytime you want to pause the video and take notes, you can. But I'm going to tell you right now, if you are formally taking high school level geometry, whether you're a public school student or a homeschooler, check out my full comprehensive geometry course. I have all my notes, everything is in there, all my instruction, super comprehensive. So I'm kind of abbreviating from that course. Okay, so in other words, let me just finish up that thought. If you want to take notes, but you're thinking about maybe checking out my program, all this is contained, so you don't have to take those notes. All those notes would be included in those courses. Okay, so let's talk about this word space. Okay, well, space is the set of all points, kind of like outer space, so you can kind of, visually kind of think of it this way. All these points here, that would be called space. Okay, moving on. Intersection. All right, so we probably have a pretty good idea what intersection means, but specifically in geometry, it's figures that share the same point or points. So line L and line M intersect at point A because point A is on line L. Okay, so if we look at line L here, there would be point A, and then over here, on line M, we have point A. So point A is both on line M and line L. So again, figures that share the same points. And you can have things like two planes intersect. Here is two lines that intersect, so it doesn't always have to be a line. Okay, so again, you probably have, some of these terms are probably new to you, but things like this probably have good intuitive understanding of what they mean. But there's a lot of terms and definitions that you're going to be tested upon in geometry. So you got to know this like very specific meaning of them. Okay, let's move forward. And now let's start talking about line segments and rays. Line segments and rays. Okay, so let's start off with line segments. So what is a line segment? Well, it's part of a line. Okay, it's part of a line. And this is the notation for it. So it's AB with a little line, a straight line. Now notice, okay, this is a line AB, okay, it has the arrows. This does not have the arrows. So be very careful here because you're going to be tested on the notation for line segments, rays, lines, etc. So here is an example of a line segment, okay? Again, it's part of a line. So this would be like a line that goes like so, but we're just going to chop off a piece of that line. And so we're going to have what we call endpoints. Okay, so the line starts there and ends there. So this is a part of a line, i.e. a line segment. Okay, so here A, B are the endpoints. And so when you write your notation like this, this is meaning this is the endpoint here, the left side, and that is the right side, just like so. Okay, so let's move on to ray. Okay, so array is basically a line, but it has an endpoint. Okay, so this is the notation. Now notice this is only one arrow to the right-hand side. So a full line has arrows on both sides like this. That would be a line AB. Line segment AB just has a line with no arrows. And then array looks like this. Okay, you have an endpoint and then it shoots out this way. That is a ray. So it starts here and then it continues on like so infinitely. Okay, so this is the endpoint, like A right there, and then B would be a point that would be on this line that's emanating from point A. Okay, so that is what a ray is. Okay, so again, I'm going through a lot of material pretty quickly, but if you're understanding all these terms and definitions, that's excellent. Again, this is the foundations to geometry. All right, let's talk about length and distance. Okay, so when we talk about length and distance, really, we're talking about the length and distance between 2 points. So here is a line segment. Let's call this point endpoint A and point B, but let's put a value on it, like if this is on a number line. Okay, so what's the distance between -3 and 7? Well, one thing you want to remember is that distance is always going to be positive. Okay, so distance or displacement is always going to be a positive value. So we're going to be looking at the absolute value of the differences, or the difference, excuse me, of the endpoints. So what we do to find the distance or length between 2 points is we take these 2 points, okay, these 2 endpoints, for example, and we find the difference, i.e. we subtract them. So -3 minus 7 is going to be -10, but we take the absolute value because distance is always positive. Okay, so by the way, too, for those of you that are taking high school level geometry, remember you should have taken algebra, been successful in algebra, because there is a good amount of algebra in geometry. And if you need assistance in algebra, get all these courses. But again, you're going to have to know some algebra to be successful in geometry. All right, so here, let's notice the notation. If I write AB like that, notice there's no line or line segments over it. So when you write just AB like so, that means the distance from A to B. Okay, so you got to be careful, because on a test, or a quiz, you'll be given this type of notation. You got to interpret what it means. But let's finish up this. So the distance between AB, absolute value -10, which of course is 10. Okay, let's move on with congruent segments. Congruent segments. So this word congruent basically means we study this like a complete full chapter in geometry. Okay, but for right now, we're going to be talking about segments or line segments, and basically it's going to mean that the line segments have the same length. Okay, so this is a big topic in geometry, congruency, along with something else called similarity. Okay, but that's for additional topics. But let's just go ahead and focus in on congruent segments. So these are segments, line segments that have the same length. So let's take a look at segment AB. So we have AB, so we can write it that way. And then we have line segment CD right here. Now they look to be the same, but I'm going to establish that in fact they do have the same length by using this symbol right there. Let me just draw it a little bit bigger. It's an equal sign with a little squiggly over it. Okay, that's congruency. Okay, so when you use that symbol, what you're establishing is that the left-hand side and the right-hand side have the same measure. In this case, we're talking about the same length. Now, this is not to be confused with one little squiggly like that. This is similarity. Okay, this is congruency, and then this is equal. All right, so again, a lot of stuff that you need to kind of know, all these notations, and this is just the beginning of geometry. There's a lot of little things like, symbols and stuff that you're going to have to get down. So that's why we're starting off with this foundation of geometry little video. Okay, so now another way we can establish that two things are congruent, okay, it doesn't have to be line segments, by the way, it could be other things as well, is by using these little hash marks right there. So let's say, let me go ahead and erase this here for a second. If I had these two line segments, and notice there's a little line right there and a little line right there, that's indicating that this and this, these are congruent segments, okay? So that's what that means. So this is often used as well. So if I go, okay, this, and by the way too, you can use like 2 or 3 to be very clear about something. Matter of fact, let me just show you one example here. We have enough time. Okay, I'm trying to get to this video, making it reasonably um, uh, not so long, but again, I'm covering a lot of information. Let's take a look at a rectangle, okay? So rectangle, opposite sides are congruent. So what I could say is that this side and this side are the same length. Now, if I went like this and this right here implies that all of these sides are the same length. Well, that's not the case for a rectangle. If this was a square, okay, that would be one thing, but for a rectangle, generally like the lengths and the width are going to be different. So I can use 2 hash marks right there to indicate that these sides are congruent and these sides here are congruent, okay? All right, so let's move forward and talk about midpoint. All right, so the midpoint is what? Well, it's a point that divides segment into 2 congruent. I should finish out 2 congruent parts. Let's call it. All right. So here is a segment. It goes from A to C, and let's say B is the midpoint. So B is the midpoint. So why is B the midpoint? Well, by definition, that means that AB, okay, the line segment AB is congruent to line segment BC. Okay, again, pretty intuitive in terms of, hey, what the midpoint is. It's basically splits this thing in half, but we want to use specific notation and definitions in geometry. All right, let's move forward and talk about bisector. Okay, what is a bisector? Well, a bisector can be a line, a segment, or a plane that intersects the midpoint. So here is a line segment, A, B, okay, and the midpoint, let's say, is C. Now I could go like this to be explicitly clear about that, but let's call C the midpoint, and you can see this line L is intersecting through C, so L would be a bisector. Okay, it could be classified as a bisector. It's bisecting that line, generating 2 congruent line segments on the left-hand side and right-hand side of this line segment. All right, again, these terms, fairly intuitive, but again, you're going to want to have very specific definitions down when you face these tests and quizzes. You just can't, you're going to have to be very precise with your definitions in geometry. All right, let's talk about angles now. Okay, so angles. So what is an angle? Well, again, we have a specific definition. It's 2 rays that start at the same endpoint. So remember, a ray has an endpoint, and then it's a line that has an endpoint like so. So if we have 2 rays, so this is a ray and this is a ray, and then I take this ray and it basically starts from this same endpoint, that is an angle. Okay, so that endpoint right here, that common endpoint, we call that the vertex. So we have a vertex, and then we have 2 sides that forms an angle. Okay, so again, going to need to know the actual definition of what an angle is. Now let's go ahead and talk about how we can name angles. So here is an angle right here. So on this side, we have point A is on this side of the angle. Point B is that common endpoint, i.e. the vertex, and then point C is on this side of the angle. Okay, so here are some ways we can name this angle. Now, notice that B is the vertex, all right? So B, the vertex, when you're naming an angle, always is going to be in the middle, all right? So we can go this way. You can go A, B, C, all right? You have to go in order. So A, B, C, so we can use a little angle notation like this, all right? It's a little angle thing just like that. So it's angle, then you go A, B, C, A, B, C. Remember, B is in the middle, that's the vertex. So if I look at this and I say, okay, angle ABC, and I want to reconstruct that, I know that B is the vertex. So BA, okay, is one side, and then BC is another side, okay, of that angle. But I also could go this way, angle CBA, or I could go this way, as well. Again, B is the vertex. It's more common to go this way, okay, kind of this way around when we're naming angles, but this technically, you could kind of get away with that as well. And then you could put like a variable or a number. So you could have right here like a 1. So I could call this angle 1 as well. All right. Now, what if we want to establish how many degrees this angle is? Well, you could put a little m like this. Sometimes you'll see this. Depending on what geometry book or textbook you might be using, some of this notation might vary a little bit. But this right here would be like the measurement of angle ABC is equal to 50 degrees. So that's what that means right there, a little m. Sometimes you'll see it, sometimes you won't. But anyways, there you go. Okay, so that's the measurement in which we measure angles in degrees. Again, I'm just doing a quick overview of a lot of stuff that you're going to have to know even in more detail, but I am covering a good amount of material in this video. All right, so let's go ahead and talk about how we classify angles. So we have all sorts of angles. We have angles that look like this. You have an angle that could look, that's an endpoint, could look like that. You can have an angle that looks like this. You can have angles that look like this. Okay, so we want to go ahead and give a classification to angles. So angles, okay, when the measurement of an angle is less than 90 degrees, we call that an acute angle. So something like that. So when the measurement of an angle is exactly 90 degrees, that's a right angle. That would be something like that. And you'll see a little square thing down in the corner, okay? So that is a right angle. When you have the measurement of an angle that's greater than 90 degrees, that's an obtuse angle, so that would be something like that. And then a straight line is actually an angle, okay? So when the measurement of an angle is exactly 180 degrees, that's a straight line like so, okay? So this is 180 degrees or a semicircle, all right? So yes, a line is an angle, okay? You want to think of that, it's called a straight angle. All right, so moving forward, let's talk about something called congruent angles. Now remember, we talked about congruency, which basically means the same measure. So here we're going to be talking about the same angle measure. So let's suppose the measurement of some angle ABC is 50 degrees, and then we have this other angle, EFG, and that's also 50 degrees. Okay, so these here have the same angle measure, so we can be very explicit about that by saying angle ABC and angle EFG are congruent. Okay, these two angles are congruent to one another. That means that they have the same angle measure. Okay, so again, congruency is used with line segments, angles, and a lot of other things as well. Okay, so moving forward, adjacent angles. Adjacent angles. So this word adjacent, things that are adjacent, basically, they share a common side. So here I have angle 3 and angle 2. Angle 3 and angle 2 are adjacent because they are side by side, but in fact, they actually share a common side. Okay, so they're not like an angle like this and an angle like that. They actually share a common side. Okay, so that's an adjacent angle, and they also have the same vertex. Okay, right there. So they share the same vertex, and they share a common side. So if you see a situation like this, we would classify this as adjacent angles. Okay, so let's go ahead and wrap this up real quick with giving you a definition on two big words that are going to be all over your high school level geometry course, and that is postulates and theorems. So when you're taking notes, okay, you're going to be taking tons and tons of notes. You're going to be writing down tons of postulates and tons of theorems, and this is really, really important in geometry, okay? But I'm just going to tell you right now what a postulate is and a theorem is. If you want to see examples of all this, again, you check out my full geometry course, and I really get heavy duty, not only to theorems and postulates, but also into proof, deduction. There's a lot going on in a high school level geometry course, but let's take a look at what a postulate is. Maybe some of you have heard this before. It's effectively statements accepted without proof. So there are some things that we can't prove, okay, in mathematics, but we just believe them to be true. Okay, so you'll see examples of this in my full course. So if we just believe something to be true, but we can't prove it, we just accept it. On faith, that is a postulate, okay? Now, then we have something called theorems. And so theorems and postulates are not to be confused. Theorems, okay, are statements that can be proved, okay? These are things that can be proved. So you might be familiar with this: a squared plus b squared is equal to c squared, okay? This is something called the Pythagorean theorem, okay? The Pythagorean theorem, okay? So that's what this thing right here is called. So by definition, it's a theorem, okay? So what does that mean? Well, this can be proved, okay? And there's some nice, elegant proofs in that. And when you're kind of studying mathematics at much more advanced levels, like myself, I have a degree in mathematics. You spend a lot of time proving things, okay? And you have to, use theorems, postulates, and all this stuff. We're really talking about logic and deductive logic, and all there's different types of logics. But again, proving things in mathematics is huge, and you do a good amount of this in a high school level geometry course by using postulates, theorems, definitions, given information, properties, etc. But that's all for later stuff. Okay, so we covered quite a bit here, all right, and this is a power through, quick overview of what would be in a first chapter of a typical geometry course, okay? If you really, really want to learn this stuff, if you need assistance, if you're like, boy, that's a lot of material, if you want to learn this and much, much more, I would highly recommend my full, complete geometry courses. I have a regular version, then I have a homeschool version. The only difference with my homeschool version is that there are chapter tests, final exams, etc., that you could pick up for that. But some of you might be interested in that as well if you're in any course. But anyways, okay, geometry is an awesome course. You absolutely need to master this stuff. So take it serious, and hopefully this video helped you out. Start, build momentum, okay, or really get you excited about this course. And if that is the case, go ahead and with your smiley face, smash that like button and maybe even consider subscribing to my YouTube channel. I've been on YouTube for 10 plus years. I have over 1,000 plus math videos, from basic math to advanced math, like calculus and everything in between. But my best math help will always be within my math help program. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.